In this video, I'll show you how we can add footstep sounds to our locomotion system. Additionally, I'll also show you how we can add a jump landing sound as well. I've provided this footstep audio zipped file to download through the description. It contains audio files from the Lyra project, and to add them to our project, we can simply right-click on the zipped file, choose Extract All, and provide the path going directly into our project folder. And if we click Extract, it will extract the file structure of the Unreal Engine project with the content folder and add the audio files in that were zipped. Back in the project, we can choose to import the changes it detected, and it will now bring in those audio file assets. Now that we've brought our audio files into our project, we can go ahead and create what is called an animation notify, which is a type of asset that can be placed within the playback track of an animation sequence, and it will call code within itself whenever it is reached while an animation is being played. First, I'm going to navigate to where we'll be creating these assets in our content browser. I'm going to navigate to the folder that we have our animation blueprints in, and I'm going to create a new folder, which I'm going to name Anim Notifies. I'm also going to bring this Anim Notify state, exit state asset that we've previously created into this folder, just in the spirit of keeping things as organized as we can. Now, I'll right-click and create a blueprint class, and in the All Classes section, I'm going to search Anim Notify and select the Anim Notify option, the one which directly inherits from the U object class. I'll name it an_play random sound from selection. And the reason I'm doing this is because we are going to treat this as a parent class and create child classes which inherit from it for separate left foot sounds, right foot sounds, and jump landing sounds. And we're doing this so that we can keep our sound separate for right and left feet. That way we don't randomly choose to play the same sound over again on the other foot, as it wouldn't sound too natural when we have a pool of footstep sounds to select from to play the exact same sound 2 times in a row. And so if we keep our pools separate for each foot, we can then make sure that we're not ever going to accidentally play the same sound 2 times in a row, as in most cases, movement is alternating from one foot to the other. Within this animation notify asset, we see what looks like a data-only blueprint, but we actually have 3 overridable functions. We're going to override the received notify function, which is called when we've reached an animation notify placed within an animation sequence track. I'm going to right-click and search play sound at location. I'll connect this node up between the entry and exit nodes of this function, and I'll go ahead and set this return value for the return node to true. Now I'll drag out from the sound input and promote this to a variable, and I'm going to name it sounds to play. I'm going to delete it out of the graph now, and that'll make it easier to convert this to an array. With that done, I'll compile, bring it back into the graph, drag out from it, and search random. I'll choose the get random array item node, and I'll plug the output pin of this node into the sound input pin for the play sound at location node. Now we need a location to play the sound at. I'll drag out from the mesh component input for the function, and I'm going to search get socket location. While this node is named get socket location, and it can get sockets added to a skeleton, we can also use it to get the location of bones in a skeleton. I'll go ahead and drag out from the in socket name, and I'll promote it to a variable, and I will name it socket name. I'll drag the return value into the location input for our play sound at location node. That's going to be it for this asset. I'll compile, save, and close out of it. Now I can right click on this and I can choose create a child blueprint class, and I will name it an underscore footstep sound underscore r. Now I can go ahead and open this up, and here we can set our socket name and our sounds to play. For the right foot, the socket name will be ball underscore r, and for the sounds to play, I'll navigate into our sounds folder, which contains our footstep sounds, and I'll select all the right foot designated sounds, and I'll drag them into the array to set all of the array elements. I'll compile, save, and I can now go back into our folder where we have our animation notifies, and I'll go ahead and copy and paste our footstep sound notify for the right foot and rename it so that it has an L instead of an R. I'll replace ball R with ball L, and again I'll go back into our audio folder and bring all the left foot notify sounds into our array. Actually, first, I almost forgot, we need to delete the sounds that are in our array for our right foot first, as we duplicated this from our right foot notify. I'll compile, save, close out, and one last time, I'm back inside the Anim Notifies folder one more time, and again, I'll create another child blueprint class from our parent class that we've created, and this time I'm going to name it an underscore landing sound. I'll open it up. For the socket name, I'm going to go ahead and just type in root for the root bone, as that'll be close to in the middle of both feet. And now, back to the audio folder, I'll grab the player land sounds from the Lyra project and drag them into the array. Looks like I forgot to hit enter when I was typing in that socket name, so I had to type it in a second time. I'm now going to show you what happens if we place one of our animation notifies into an animation. You do not have to follow along here, as we're going to be creating an animation modifier to automatically place these in our animations. I'll go ahead and right click into the notify track here, and I'll choose to add a notify, and I'll select one of our footstep sound notifies. As you can hear, when we cross over it, it plays a footstep sound. Instead of placing these manually for every single one of our animations, we'll place them automatically using an animation data modifier. Back in our animations file, which contains our animation blueprints, I'm going to create a new folder named Anim Modifiers. Inside of it, I'll right click and I'll create a blueprint class, and under the all classes section, I will search Anim Modifier. And here we have the animation modifier option. I'm going to select it, and I am going to name it AM underscore footstep sounds. Inside of it, we have some overridable events. I'll go ahead and select on apply and on revert. Now, if you've never used animation modifiers, don't worry, I'll be walking you through the whole process of using this one, though this won't be a dedicated video on animation modifiers. Know that there are many things you can do with them, and the ways that you can access data from animations, to write to curves, to place notifies, notify states, and the list really does go on. But we will be keeping it relatively simple in this video, though some patterns that I will walk you through in this video will be applicable to many other animation modifiers that you may be creating in the future. To begin, I'm going to go ahead and create two functions. I'm going to name one apply modifier, and I'm going to name the other revert modifier. I'm going to create an Anim sequence type input for each of these, and I will name it Anim sequence in. With that done, back in our event graph, I'll connect each one to the appropriate event. And I'll plug the animation sequence event output into the function inputs. Inside of our apply modifier function, I'm going to create a for each loop. Now I'm going to create a new array variable, and I'm going to name it Notifies to remove. I'll change its type to be a name, and I'll set it to be an array. I'll plug it into our for each loop, and I'll go ahead and compile. That way I can set its default values. I'm now going to navigate over into the Anim Notifies file and copy the text of one of the names for our Footstep sound Notifies. We'll be placing the Footstep Notifies automatically, but the jump one manually. So the Notifies we'd want to remove when we apply are Footstep sound R and Footstep sound L, and this is because we may adjust settings and want to reapply our modifier, and if we do, we want to remove all the Notifies we've already placed that we will be replacing. So that's the first thing that we do. So now that we have a for each loop for each of these, we need to actually remove the Notify. I'll go ahead and get the Anim sequence in function input. I'll drag out from it, and I will get a remove animation notify events by name function. I'll connect that into the loop body, and I'll connect up the array element for each loop pin to the notify pin of the function that we are calling here. With that done, once we've completed this loop, we're going to do another for each loop. I'll go ahead and copy and paste this node, and I'm going to create a new array variable. I'm going to name this feet definitions. I'm going to open the content browser, and I'm going to right-click in this Anim Notifies file, and under the blueprint section, I'm going to create a new structure, which I will name f foot fx foot definition struct. The first variable in this struct is going to be a name, and it will be named bone name. I'll add another name variable, and I'm going to name it notify track. And finally, I'll add one more variable, and its type is going to be an Anim Notify class reference, and I'm going to name it Anim Notify. I'll save this, and I'll change the type of our feet definitions variable to be that foot fx definition struct. I'll compile, and I'll add two array elements, one for the right foot and one for the left. For the bone name, I'm going to choose ball L for one and ball R for the other. For the notify track, for the left one, I'm going to name a track left foot FX, and for the right, right foot FX. Finally, for the animation notify, I'm going to choose our footstep sound L and footstep sound R respectively for both array elements. With that done, I'll go ahead and plug our foot definitions array into our for each loop. And now I'm going to create another function to try to keep things organized here. This one I'm going to name process foot. It'll additionally allow us to run the same set of code for each item in this array to keep things more optimized as well. I'll drag it into this graph and connect it up to the loop body. I'll give it an anim sequence in input, just like our function that we've previously created for applying the modifier. and I'll give it a second input. This is going to be that foot definition struct we've created, and I'm going to name this foot definition. I'll plug our array element pin into the foot definition input, and I'll plug our anim sequence in function input for our apply function into the process foot function's anim sequence in input. With this done, I'll go ahead and enter into the process foot function. And now this is where the bulk of our logic is going to be for determining when we're taking a footstep and when we need to play that sound. The first thing we're going to do is add an animation notify track. I'll go ahead and get our anim sequence input. I'll drag out from it and add in search add animation notify track. I'll get our foot definition input for our function. I'll split its struct pin, and I will plug in the foot definition notify track name into our input for the notify track name for this add animation notify track function. Next, I'm going to calculate the speed of the foot for each frame in the animation, and this is how we're going to determine whether or not we should place an animation notify. To calculate speed, we'll subtract the position of the foot in the previous frame from the current frame. But, unfortunately, we don't have a previous frame on the first frame of an animation, so we're going to go ahead and preemptively set our previous foot position before we begin iterating through each frame of the animation to calculate the foot speed for each frame. I'll go ahead and right-click and search anim sequence and get our anim sequence in input. I'll drag out from it and I'll call a get anim pose at time function. I'll leave the inputs at their default for now. From the pose output, I will call the get bone pose function. For the bone name, I'll go ahead and get our foot definition input and connect up its bone name attribute, and I'm going to set space to world for the get bone pose node. That's super important. Make sure you do that. Otherwise, it'll be in space relative to the parent bone. Next, I'll go ahead and split the struct pin for our return transform, and I'll drag out from the location return value and create a new local variable named previous foot location. I'll connect to the execution pins between the last node we've called and this one together. And now we need a couple more local variables, and I'm going to go ahead and create them now. I'm going to create a current foot location variable, which will be a vector. Next, I'm going to create a boolean named hasFoot unplanted. We'll be using this to track whether or not the foot is or isn't unplanted while we're iterating through the animation. And finally, two floats. One is going to be current time, which we'll use to track the current animation time as we iterate through it. And next, the current foot speed, which we'll be using to track the foot speed. Now I'll go ahead and set the hasFoot unplanted boolean to false. Next, I'm going to get a for loop, and we'll be using this for loop to iterate through each frame of the animation. And I've been saying each frame, but that's really a simplification, as we're going to determine a sample time that we can set manually when we apply the modifier, and we'll be iterating through sample steps based on the time frame of each sample. So I'll go ahead and create a sample step float, and I'll set its default value to 0.0125. For this for loop, I'm going to set the first index to 1, And now I'm going to grab our Anim sequence in function input, drag out from it, and call a get sequence length function. This is going to return the length of the animation sequence in seconds, and we're going to divide this by our sample step variable. With that done, we can truncate this float into integer and plug that in as our last index for our for loop. Now, we'll need to convert our index back to a time so that we can look up animation pose values at certain times within our loop. So I'll go ahead and multiply the index of our for loop by our sample step, and that will give us the current time, which we'll use to set our current time local variable. With that done, I'm going to check if the index is equal to 0. If that is true, then we're going to move on with our code, but if it is false, then we're going to set the previous foot location, which I actually misspelled, so I'm going to fix that quickly, using our current foot location variable. However, if this is true, we're not going to do so as we've already set it preemptively here. With that done, we're going to get another anim pose at time, so I'll copy this grouping of nodes here and paste it. I'll plug it into the true output of our branch node, and I'll also plug in the output pin of our set previous location into it. I'll go ahead and control click to grab both of these inputs, and I'll get a reroute node. That way we can keep things a bit more compact and organized without having too many lines crossing over each other. Now for the time input of our get anim pose at time, I'm going to plug in our current time. And for the return value location output, I'm going to set our current foot location local variable. With that done, we can calculate our foot speed. I'll get the current foot location and the previous foot location. Now I'll subtract the previous foot location from the current foot location. We now have the difference between these two, which would be the vector of our velocity. I'm going to go ahead and get the length of this vector along the x, y axes and ignore the z axis. And that'll give us the speed along the horizontal plane, but discount the vertical speed of the foot, as that's not necessary for what we're doing here. And now I'll divide this value by our sample step variable, and that will change its measurement. Right now, this is the difference in 0.0125 seconds. By dividing it by our sample step, we make it to the change in location, the difference in location over a single second, which makes this resulting value independent of our sample step value. Otherwise, we need to adjust all settings and all of our speed thresholds, which we haven't yet created, when we change our sample step, which is not something we want to do. From this calculation, I'm going to set our current foot speed variable. Now that we have our current foot speed, I'll go ahead and get a branch. And for the input pin condition, I'm going to plug in our hasFoot unplanted node. If our foot is unplanted, we're going to check if our current foot speed is less than a setting that we're going to create now. We're actually going to create two of them. Two float settings, that is. One which is going to be named foot planted speed threshold. And the other is going to be named foot unplanted speed threshold. So if our foot is already unplanted, we're going to check if our current foot speed is less than our foot planted speed threshold. And if that is true, Then we are going to add an animation notify event. I'll grab our anim sequence in input, drag out from it, and search add animation notify event. I'll go ahead and grab our input struct for our foot definition, and I'll plug the track name input in and the foot definition in as well. And finally, I'll get our current time variable and plug that in to the start time. Finally, we've determined that the foot is planted, so we need to set has foot unplanted to false. I will connect up this branch to the true value of the previous one and raise it up to give us some room and create our reroute node to keep things organized. Now, I'm going to copy our condition here, where we're checking our current foot speed, and I'm going to replace the foot planted speed threshold with the foot unplanted speed threshold variable, and I'm going to replace the less than node with a greater than node. Definitely remember to do that. Don't be me and completely forget and wonder for a long time why this animation notifier doesn't work, and then manually go through and place everything in all the animations manually and decide not to make this video, and then realize you had the same statement in both conditions, and yeah, don't be me. Now that we've determined that we've exceeded our unplant speed threshold, all we need to do is tell the loop, tell the system here, that our foot is now implanted again by setting this variable. That way it is able to execute the code to check if it becomes planted again. For the default values for our foot planted speed threshold, I'll go ahead and set it to 10. For our foot unplanted speed threshold, I think I'll go ahead and set that one to 100. We may need to adjust these further, but I think that will be a good starting point. I'll go ahead and click the eye next to each of these variables to expose them and make them editable as we apply an animation modifier. And now I'll compile and save this, and that should be all the steps here complete for applying the modifier. Hey everyone, Editor Ethan here. I made a mistake when recording the video and didn't catch it. You want to create a has feet unplanted it start boolean set to instance editable so that you can set it for each animation you're applying this to, and when you apply these in bulk, you'll want to select the animations where the character is starting from idling and where the character is in movement at the beginning separately, and apply it to those groupings separately so that you can set this variable accordingly. Otherwise, it may expect the character to be standing still when the character is moving at the start of an animation and place an unnecessary animation notify. I noticed a few unnecessary notifies when I apply this during the recording, but I chalked that up to threshold variables not being set properly for determining the minimum plant and unplant speed thresholds, and so I did not catch that until later on. So you'll want to make this part of the graph look like this here, and set this boolean according to the animations that you are applying the modifier to. And with that out of the way, let's get back to the recording. Back in our event graph, we still have our event that reverts the modifier. I'll go ahead and enter into that function now. And this one is much simpler. We're going to get our feet definitions array that we've created and bring that into a for each loop. And so we're going to use this for each loop to get the notify track of our definition and remove that track from our animation. So I'll go ahead and get our anim sequence in input, and I'll call a remove animation notify track function. And I'll plug in our array element for our notify track. Now that is complete, let's test out our animation modifier. I'll go back into our animations folder where we have the animations that we're using, and I'll open up that forward jog loop animation again. And now I'll go ahead and create an animation data modifiers window. And I'll add our footstep sounds modifier. I'll right click on it and choose to apply it. And it didn't do anything. That's because I forgot we need to disable enable root motion and force root lock so that it processes the full movement of our animation, root motion included. With that done, I'll try applying this again, and there we go. We're now playing footstep sounds. These will not line up perfectly with sync markers, or may not, and that's fine, as the sync marker isn't always placed in the spot where the foot touches the ground. It may be placed at a slightly different point in the character's gait. Again, this is another case where we do not need to apply something to each and every animation manually, so instead we can select our animations that we want to apply it to, right click on them, and in this case I'm going to bulk edit these to disable their root motion and force root lock. So under asset actions I'll choose bulk edit via property matrix. And I'll disable both of those settings for all of these and save them. I'll leave this open as we'll want to re-enable them once we apply the modifier. And now I'll right click on our animations and I'll choose the add modifier option, and I'll add our footstep sounds animation modifier and apply it to all of these animations. Now, it may take a few minutes for this to process and apply, so I'll go ahead and cut the video and return once this has applied to all of these. Alright, the animation modifier has been applied, so I'll save all of these animations. And I'll go ahead and re-enable enable root motion and force root lock for each of these. Again, I'm going to save all of them. Now, I only applied the modifier to our walking and jogging looping animations, as that was the folder I was in. We still need to apply these to more of our animations. And so I'm now going to go through the rest of these folders and apply the modifier to the animations, and I'll return and resume this video once that process is complete. I've applied the modifier for adding the footstep animation notifies to all of the grounded locomotion animations, but we still have the jump landing to handle. Here we have a unarmed jump recovery additive animation, and this is where we're going to play our jump land sound, about right here where that first foot is hitting the ground. So really the foot hits at the start of the animation. First frame this foot is on the ground, so I'm going to try placing it at the very start. So add the landing sound notify that we've previously created, and these leftover animation notifies are from Lyra and aren't required. They're just in the asset from migrating it over in a previous video. We don't need those, though they don't have any effect if they're there. I've just deleted them since we don't really need them. So with that added, if I play and jump, we have landing sounds, and if I walk around, we can hear footsteps as we are walking, as all the playback of the sound is handled in the animation notifies. So that is it for adding footsteps to our system.